Hello everyone, here is a question from atomic structure. In hydrogen spectrum, the shortest wavelength in the Balmer series is lambda. In that case, what would be the shortest wavelength in the bracket series? This question already gave us 4 clues. Shortest wavelength, Balmer series, shortest wavelength, bracket series. When we will have shortest wavelength, if the energy difference is larger, then we will have the shortest wavelength because energy and wavelength are inversely proportional to each other. So, let us say we have stationary states. When n is equal to infinity, if an electron jumps from here to all the way to the ground state, then we will have the shortest wavelength, but that would become Lyman series. Here they are mentioning Balmer series. So, for Balmer series, if we want to have the shortest wavelength, then the electron that is there at infinite stationary state has to come to the first excited state. So, this is Balmer series, and then if it is n value is equal to 3, then that is Paschen, and if n value is equal to 4, then that becomes bracket, isn't it? So, n equal to 1, n equal to 2, n equal to 3, n equal to 4 here. Here shortest wavelength in both the cases. That means the n2 value is infinity. So, in the case of Balmer, if we are talking about, then n2 value is infinity and n1 value is 2. For bracket, the n2 value is infinity and n1 value is 4. Let us first calculate the energy difference. Let us keep it as 1 by lambda. 1 by lambda is equal to the Rydberg constant times 1 by n1 square minus 1 by n2 square. That is the formula here that we have to apply. So, in the case of Balmer series, what will happen? 1 by lambda is equal to the Rydberg constant times 1 by n1 square will be 1 by 4 minus 1 by infinity square that we can neglect. So, basically if 1 by lambda is equal to RH by 4, then lambda value will be 4 by Rydberg constant, isn't it? So, we found the value for the Balmer series. Let us calculate the value for the bracket series. So, let us keep it as 1 by lambda prime just to differentiate, RH times 1 by 4 square, that is 16, 1 by minus 1 by infinity square that we can ignore, and therefore 1 by lambda prime is equal to RH by 16. We learned that lambda is equal to 4 by RH, isn't it? So, therefore, this one we can write it as lambda prime equal to 16 by RH. So, that means we can write this one as 4 times 4 by RH. So, that means lambda prime here will be equal to 4 lambda, isn't it? If we substitute that. Therefore, option 2 is correct.